just a quick recap. You go to your Steam library, your Steam apps, Common, BeamNG Drive. You open up the GameEngine.zip. You go to Art. You go to Shapes. You copy the particles to your clipboard. Then you go to your user folder where your levels are. Go to your levels. Go to the level that you want to modify particles in. Go to the art folder. If there's not an art folder, create an art folder. Go to the shapes folder. If there's not a shapes folder, create a shapes folder. Inside the shapes folder, paste All right, what I'm going to do is go through this BeamNG documentation on the particles. You can follow along if you'd like to. What we're going to do, I'm going to read a little bit, and I'll explain a little bit. I'll read a little bit, explain a little bit. The first thing I want to say, though, before you ever do anything with a particle, when you open the particle editor, whatever work you do, be sure you hit Save Emitter to Current Level instead of Save Emitter to its file, unless you want that change to that particle to reflect in all the levels. Well, you may say, well, why don't you just make a new particle? Well, every time I try to, and I hit this, see red everywhere. The particle editor is used to create and edit components. A particle is made of an emitter and a particle. You can think of an emitter as a shower head, for example. How a shower head, you can adjust the water velocity. You can change the type of spray that comes out, whether it's a pen stream, a bloom, a fan, or a jet, or the particle itself would be the water in that case. The water, what color it is, how big the drops are. Does gravity affect it? Does wind affect it? Basically things like that. We'll get into particles later. We're going to talk about the emitter now. So here is an emitter here. To place an emitter, you simply go to Create Object, Particle Emitter. Place the emitter. Now, to know which particle you are looking at, you have all these numbers here in this drop-down emitter. All these numbers are in this. These are all the different particles that are currently available to you to use. Since making a new particle seems to crash the game, then it's advisable that you only modify existing particles. Surely in your level you're not going to use 80 different particles. You can find one to modify to make it do what you want. I'm going to go with sparks. I just like the sparks. It's a good thing to show an example with. So there's two things to note here. This is actually the emitter. Now when you want to edit that particle, you have to press the particle editor, but face a little off to the side because it's going to put this directly in front of you. If you look at the particle as you are editing it, it's going to place it on top of the particle, making it difficult to see what you are doing. So I recommend you place that off to the side. Now the default emitter is stars. We want it to be the sparks. Now if you're confused, don't feel alone because only a few of these have descriptions. So back to the particles folder that I had you copy into your level, you'll see managed particle emitter data. If you open this and go down to like line 192, I think it is, 129, line 129. If you go to line 129, it will start if you go to line 129, you will see where these particles start. And the reason you're coming in here is because each one of these numbers has the name of the particle that's assigned to it. It can tell you which emitter is which. Now you can assign different particles to different emitters, but for the most part, what you see here, when you pick this is what you'll see in the game. Like sparks is number 1. For example, number 56, 57, and 58 are the little black pieces of plastic that break off a car when you crash. Also keep in mind, these are not in complete order. They're out of order a little bit. See, black or BeamNG plastic chunk 1, chunk 2, chunk 3, and number 50, for example, is water splash. Water wheels is what it's called. That's the water that a river makes on the tires. All these images are all the textures with the existing particles. You can make your own, but you need to make them either a DDS or a PNG file with an alpha transparency if you want it not to have a big black box around it like this when you see it. There's also another file that has all the particle information. I'll get into all this stuff another time. Just for an example, see, that's water splash, number 50. The average workflow to create a new particle is to first create a new emitter and then the related particle. So what you'll do is you'll go somewhere onto your level and you'll say create object, create new emitter. That's what it's saying doing. Sometimes it's hard to see where this emitter is. I'll right click on it and say move selection to camera, because you never know, it could be inside of something or on the other side of something and you ain't seeing your actual particle that you're wanting to look at. So that's what it's saying doing, to create a new emitter. Now to edit that emitter, you have to say particle editor. It's not going to automatically show you the particle that's selected here. It's going to show you the default, which is stars. This particular particle is number 1. This is sparks. So if you don't have it open, you need to open your inspector. This will show you the particle that you're editing. Change this to 1. That would be the sparks. Now remember, when you are done editing the particle and you go back to do other work, it's going to disappear. But don't worry, that's not your particle emitter. That was just the preview that it's talking about here. When entering this edit mode, a temporary particle emitter is placed in front of the camera to conveniently to be able to see any changes without having to place an emitter manually. This is removed once leaving edit mode, so you don't have to actually have this. If you got a waterfall back there and you already got your particles and you just want to edit the water, you just make a new particle and then you just find the waterfall, whichever one it is, waterfall. I think that one is actually labeled waterfall spray, for example. You can do your editing, save it, and it'll affect the waterfall. See, it's up to you how you do that. Just remember, when you save your file, save emitter to current level, and you'll see up at the top, saved emitter to levels, your level, art, shapes, particles, and to that file that we talked about just a minute ago in here. That was the purpose for putting that folder into the level, so that you do not write to the install location, which is the Steam library, Steam apps, common, BeamNG drive, and overwrite the game engine.zip. I think that's what it's overwriting. I know you edit. I know if you say save the file, it's saving all. It's saving. Just be sure to save the emitter to the current level. All right, so let's get back to our sparks. I don't know why I want to call that rust. You want to say rust. It's sparks. The emitter is the object that fires the particles. In this tab, you'll find all the properties that determine its dynamics. So this is what I was referring to when I talk about a shower head shooting out the particle. All these things here are all these things. So we got the ejection period millisecond. Now what this is, it's the time between each particle ejection in milliseconds. See, right now, this is the fastest you can have them, come out one after the other. If you want them to come out more spaced out, you would increase this number. So think of more is less and less is more. That'll help you understand that a little better. Now the period variance is randomized ejection period in milliseconds. So the more this number is, the more random it'll kind of just put them out. Some close to one another, some farther apart. This could be useful if you're making like a cascading waterfall or something and you don't want it to look exactly right, the same every single frame. So this kind of gives it a little variety. You know, water's kind of like that, you know. But that would be a good reason why you would use something like this. Now the next thing is the ejection velocity. That's the particle ejection velocity. That is basically how fast it will shoot that particle out of that emitter. Like I was saying with the shower head, how it shoots out that water at different speeds. That's exactly what this does, at different speeds. The velocity variance is just a variation of several different speeds. The more you increase this, the more variation it will shoot them out at different velocities. So not only can you have it shoot out different velocities, you can have it shoot out various times in between each thing. Like if you think of somebody welding, you think of like, you know, sparks popping in, you know, that's kind of like what this would kind of be used for. But I mean, there's 1,000 other things it can be used for, but that's just one example. The next thing we're going to talk about is the ejection offset. That's the distance along the emitter's z-axis in which it ejects the particles. Basically, think of this as an offset. If the emitter is here, it's going to offset along the z-axis away. Now, I really can't think of a reason why you would have this do this, but nevertheless, that's what it is. It'll eject it farther and farther away depending on how far that number is. And if you wanted to have a random amount, basically the ejection offset variance would have them basically breaking off, or spawning with different origins. That'd be the right way to say this. The ejection offset is an offset of the particle's origin, where it originates from the emitter. And the variance would be a variation of that. So now we're going to talk about the theta minimum, the theta maximum. That's the minimum and maximum angle on the horizontal plane to eject particles from. One way you can think about this is think of a Chinese fan. If the theta minimum is up to the maximum it can unfold 180 degrees, basically that is full fan. If this is lower, it'll basically collapse the fan into a stream. As this increases, the fan gets wider, up to 180 degrees. Now, whether you are increasing the minimum or the maximum up to 180 degrees, the results will be the same. However, if you increase the maximum, also what it'll do is it'll start to clockwise close the fan so that it is pointing down. All right, the next thing we're going to talk about is the fill reference velocity, or the Phi reference velocity, and the Phi variance, Phi, whatever it is. Angle on the vertical plane to eject particles from. All right, so in order to understand this, think of a lawn sprinkler. To understand fill reference velocity, think of a lawn sprinkler. You know, the kind that sprays one way, then it sprays the other way. All right, now imagine a dummy picking that up and holding it to us really close to himself. And then he starts turning in circles. That is what the fill reference velocity will do, up to 360 degrees. Maybe that dummy isn't turning all the way in a circle. Maybe he is. If he's turning all the way in a circle, then this is what you'll get. He's spinning around in a circle. Now keep in mind, you will not see fill reference or fill variance changes unless the theta minimum and theta maximum either or above 0. So unless this is a fan, to some extent, you're not going to see anything when you change the fill variance. Now imagine that same dummy holding that sprinkler, except that the sprinkler, instead of having holes just along the top, there was holes all around it. That is what the fill variance will do. The more fill variance, the more it will shoot water off in every direction up to 360 degrees. With this at 360, this at 360, this at 180, you can think about a ball where the center of the ball is dispersing out particles equally in every direction. That is what your field reference, field velocity does. Now the softness distance is the distance at which the particles will be faded based on the distance between the particle and the seam geometry. That will not really show you anything in here because of this level is like it is. I'll come back to this. The next thing is the ambient factor. That's the amount of ambient lighting affecting the particle. When I want to make water splashes disappear, what I typically do is I increase the ambient factor above 0 so that the particle doesn't exist or you don't see it. Advanced override advanced. If false, particles emitted in the same frame have their position adjusted to prevent clumping. Now to illustrate this, what I'll have to do is change this again so that we can see something that would have clumps. All right, now we're going to talk about when you got a particle that's bringing your system to a crawl. The high res only setting, if disabled, particles are drawn at half the resolution, improving performance. And there you have your improved performance. This is especially useful when you are making like big columns of smoke. Use backlighting. Enable dynamic lighting on the particle. Backlighting, the amount of backlight the particle receives. Think of some smoke in a room. Think of a light shining on the smoke, and then you turn the light off. You turn the light on. Turn the light off. Turn the light on. There you go. Render reflection. If true, particles will appear in water dynamic reflections. Well, we need water for this. All right, the next thing on the list is render reflections. If true, particles will appear in the water's dynamic reflection. Off, on. If you are editing a emitter, like these sparks, you can add more than just sparks to the emitter so that multiple things are coming out of the emitter. See, now we have sparks and we have leaves. Now we have splinters, sparks, and leaves. Now we have volcano smoke, splinters, sparks, and leaves, and they are quite intensive. So that would be one you would turn high res off if you wanted to have all that happening. You can't see it, but there's a little trash can right here that you can click to remove the additional particles. The blend style. Think of the, for blend styles, blend mode for the particle. If you've used alpha effects, then you know about the pre-mul, sub, add alpha, or what I call lerp alpha, normal, additive, subtractive, pre-mul. Now, I haven't messed with this stuff a lot. I rarely ever mess with pre-mul alpha effects or subtractive. Mostly I'll stick to normal. Override advance. What override advance does, if it's false, the particles emitted in the same frame have their position adjusted to prevent clumping. So if we turn this on, we will not have any more clumping as they are coming out of the emitter. Now look at the direction that they're facing, left to right, which this is the image of the particle. That's the direction that it's facing. What this is saying is if true, particles will be oriented to face the camera. So now do you see that they've rotated the different directions? You can see this with this advanced override off a little better. Now if we orient the particles and turn off the orientation, you see that the direction of this changes to this. Softness distance. Distance at which the particles will be faded based on the distance between the particle and scene geometry. If this is lower, you will see the particle more. If this is higher, depending on where it's at, how far the distance is, it kind of blends it into the scene. That's the only way I can describe it. It blends it into the scene, but what it really makes it look like is that it's more transparent. The next video we'll talk about the actual particles.